Hi guys, so for today's video, we're down to chapter 8 and let's go. Chapter 8, Subnetting IP Networks. Chapter 8, Sections and Objectives. Subnetting an IPv4 network. Addressing schemes. Address schemes. Subnetting an IPv4 network. Broadcast domains. Other devices. Services. Switches. Propagate. Broadcast out all interface except the interface on which it was received. Problem with large broadcast domains. Host can generate excessive broadcasts and negatively affect the network. Reduce the size of the network to create smaller broadcast domains. These smaller network spaces are called subnets. Reasons for subnetting. Reduce overall network traffic and improves network performance. Enables an administrator implement the security policies such as which subnets are allowed or not allowed to communicate together. Octet boundaries, IPv4. Class subnetting. Prefix len. This will be the example of classless subnetting. The subnet mask. This is on how you will do the subnetting. So for example, 1100000 1001010100000 and 00000 2 0. Host bit is 2 7 128 minus 2. Okay. Magic number is 128. Okay. So on how you can solve the subnetting with the magic number, you just need to find the number that consists of SN or H, and then you will know the classless subnetting example. Creating two subnets. Subnet topology. rpconfig general. Use the following IP address. Advance. Magic number 128. Start at 0 and add 128. Oh, subnetting formulas. Calculate number of subnet formula. 2 over 2 divide n or over n. N is bits borrowed. So n. Subnetting formulas. 2 over n minus 2. The n is the number of bits remaining in the host field. So the 7-bit remaining in the host field is the 0000. 2 to the 7th power is 128 IP address per subnet. 2 to the 7th power minus 2 is 128.126 IP address per subnet. Creating 4 subnets. 26 subnetting topology. Creating 4 subnets. Continuation. This is on how you create or solve the subnet topology or subnet ping. Then that's the gigabyte internet and the serial internet. Creating 4 equal size subnets. Creating 8 equal size subnets. Creating subnet with a prefix 16 or 16 prefix. Creating subnets with a 16 prefix. Calculating the hosts. 0, 0, 0, 0. Creating 1000 subnets with 8 network. So there are the host field is always H. Then the N is the number of bits. So there are 10 number of bits. So you just 2 to the first power, 2 to the second, 2 to the third, 2 to the fourth, and so on. So resulting 18 subnets. So 10 subnetting based on reverse. Number of subnet is 2 because 1, 2 to the n power. So 2 to the 1 power is 2. While the 2 to the 2 to the second power is 4. And 2 to the third power is 8. While the last one is 2 to the fourth power is 16. So times 2. Times 2 times 2 times 2. More likely like that. Then the number of hosts is 126. You always minus it to the subnet mask on the last part. This one. Where's the on before you get the number of hosts, you need to know the number of subnet. So the network is this and the host is this. 2 to the first power. 2 to the first power is 2. 2 minus 128 is 126. That's it. That is how you get the number of hosts. I hope you understand. Subnetting based on network requirements. Host devices used by employees in the engineering department in one network and management in a separate network. Network requirement example. This is these are the example of corporate network or network requirement example. Continuation. Traditional subnetting with addresses. So that's the example. This would be the traditional variable length subnet mask or VLSM and subnet varying sizes. Basics VLSM in practice. VLSM chart. VSLM example. One network 200 hosts. 2 to the 9 is 512. And that's all. Addressing scheme. Network address planning. So, planning IP address assignment. Student LAN, faculty LAN, admin LAN. Planning to address the network. Each host in internetwork must have a unique address, need proper planning and documentation, must provide control access to servers from internal hosts and external hosts. Assigning addresses to devices. End users, clients, servers, intermediary device, and gateway. Design consideration for IPv6. The IPv6 global unique address. This will be the structure of the IPv6 global unique address. IPv6 subnetting is not concerned with conserving address space. IPv6 subnetting is about building and addressing hierarchy based on the number of subnetworks. IPv6 link local address is never subnetted. IPv6 global unique address can be subnetted. IPv6 global unique address normally consists of 48 global routing prefix, a 16-bit subnet ID, and a 64-bit interface ID. Subnetting using the student ID. IPv6 subnet allocation. So that's all for the chapter 8, and I hope you understand all the things that I have said here in chapter 8. I hope